Hess's law states that if a reaction can be specified using a series of steps, then the sum of enthalpies of all the steps is equal to the enthalpy of the overall reaction. But first we need to manipulate these steps to match that reaction before we sum them up. So according to Hess's law, when a reaction is reversed, you flip the sign of the enthalpy. So for example here, we want to flip the reactants and the products such that acetylene ends up on the right hand side to match that reaction. So we flip the sign of the enthalpy. Now if we multiply or divide a reaction by an integer, then we can do the same for the enthalpy of that reaction. So here we have 1 carbon and 2 in the overall reaction, so we multiply this step by 2. And therefore we multiply the enthalpy by 2. And in this final step, the hydrogens match, so we don't need to do anything to this step. And now if we add all the steps, we obtain the overall reaction, and therefore we can add the enthalpies of the individual steps to obtain the enthalpy of the overall reaction, which we'll cover in an example problem. Let's find the enthalpy of this reaction given the following reactions with the following enthalpies. So here ammonia is on the right hand side, but it's on the left hand side in the overall reaction. So what we do is reverse this reaction by flipping the reactants and products. So we flip the sign of the enthalpy, and we have 1 mole of ammonia, so we need to divide this by 2. And we thereby divide the enthalpy of this reaction by 2. Now for the next step, we have methane on the right, so we need to reverse this reaction also. So we flip the sign of the enthalpy. And here we have 2 hydrogen cyanides on the right, but 1 on the right in the overall reaction. So we divide through by 2. And do the same for the enthalpy of this reaction. Now if we add all these together, we get the following on the left hand side. And the following products on the right hand side. So on the right hand side, we have a total of 7 on 2 moles of hydrogen gas. And now if we cancel out a half from both sides, we get 7 on 2 minus a half, which is 6 on 2. Then the carbon solid cancels out, and the nitrogen gas cancels out. So we can see that we obtain the overall reaction. And therefore you can sum these enthalpies, which gives you the enthalpy of the overall reaction, using 3 significant figures. which is endothermic.